Hi guys, welcome back to the channel. So this is example 7.3, chapter 7, safe bearing capacity of a shallow footing. Terzaghi's formula for the net ultimate bearing capacity QNF, total pressure less overburden pressure for a stick footing, is QNF equals CNC plus gamma Z NQ minus 1 plus 0.5 gamma times BN gamma. For a certain soil, the cohesion Cu is 50 kilonewtons per meter squared. The unit weight is 19.2 kilonewtons per meter cubed. Calculate the the ultimate bearing capacity for a strip footing of width B equals 1.25 at depth Z equals 4.5 meters. Considering the shear failure only, calculate the self-load on a footing 6 meter long by 1.2 meters wide using a load factor of 2.5. What other soil properties should be taken into account in determining the safe load on this foundation for a certain cohesion? I don't know for sure, but it's like, isn't the compressibility? Because that's it had already said about the ultimate bearing capacity, but the serviceability capacity is when it starts to settle, and then it's gonna move all over the place. I'll just read that again. Terzaghi's, yeah, right then, you can just watch it back actually. You can watch the video back. For a certain soil cohesion, C is 50 kilonewton per meter squared. The unit weight is 19.2 kilonewton per meter cubed. Calculate the net ultimate bearing capacity for a strip footing of B equals 1.25 at depth Z equals 4.5. Consider shear failure and calculate the safe total load on a footing 6 meter long by 1.25 wide using a load factor 2.5. Okay. Solution. Since the soil at any depth Z below the surface is already stressed with the weight of overlying soil, equals gamma Z kilonewton per meter squared, it is usual to base the calculation on the net ultimate bearing capacity QNF equals QF minus gamma Z, which is the pressure additional to the existing pressure which will cause the soil to fail in shear. For the given situation, phi equals 0, n gamma equals 0, and nq equals 1. Terzaghi's formula becomes QNF equals Cu over Nc. Skempton's formula for Nc for undrained saturated clay is Nc equals 5.14 brackets 1.1 plus 0.2 B over L times bracket 1 plus the square root of 0.053 BD. For the strip foundation, B over L equals 0, D equals 4.5 divided by 1.25 equals 3.6. NC equals 5.141 plus 0.053 times 3.6 equals 7.38. QNF equals 50 times 7.38, 369 kilonewton per meter squared. That sounds massively high. The safe bearing pressure with a factor of safety or load factor F is then QS equals QNF divided by F. Oh yeah, plus gamma Z. It should be noted that the strength provided by the overlying soil is always present and does not therefore need to be reduced by a factor of safety. For the rectangular footing, NC equals 5.14, got all that, 1 plus 0.2 times 1.25 over 6, 1 plus 0.053 times 45 over 1.25 equals 7.69. QNF equals 50 times 7.69 is 384. And then 380, the QS safe working load is 384 divided by safe, factor of safety 2.5 plus 19.2 times 4.5, 240.2 kilonewton per meter square. Oh. Safe load on footing QS equals QS plus area on footing 1801. The other property of the soil to be taken into account is its compressibility. Yeah, since this affects the amount and rate of settlement of the foundation. Yeah, you can. It said I think you can do a laboratory test on that to determine what it is. Well, hopefully you found this video interesting. Please like and subscribe to the channel. I'll go over this video and explain it again. Thanks for watching. See you in the next vid.